ENVT 4402 Topic 9 Attitudes towards risk and risk management. So far we have considered models where state of nature, that is the values of parameters, are known. These parameters could be future cost and benefits, biological growth rate, carrying capacity, population size, etc. We have assumed generally single value estimates of parameters. This is consistent with an assumption that the future as well as the present is known with a high degree of certainty. Yet clearly the values of many parameters, internal and external to the project or decision maker or to the policy analyst, are uncertain. It is important therefore to provide decision makers with adequate information relating to the margin for error surrounding single point estimates of parameter values. While incorporating estimating the error surrounding a single point estimates, a concept is used like risk and uncertainty. However, a distinction is sometimes made between the terms risk and uncertainty. Risk is measurable. It refers to situations with known probabilities. Uncertainty, in contrast, is vague. It refers to situations with unknown probabilities. In practice, the distinction is a fine one. A probability may be assigned to a particular event, but the probability is seldom known with complete certainty. Conversely, few events are so uncertain that probabilities cannot be assigned if it is thought worthwhile to do so. In this lecture, unless otherwise mentioned, we treat them interchangeably. But it is better to be conscious of this distinction while you are reading the literature. It has been traditionally argued that the public sector decision makers or policy analysts should evaluate projects or programs on a risk-neutral basis. This implies that decision makers should be indifferent to the dispersion or variability of the expected returns as a result of that risk and accept those activities with the highest expected returns regardless of the risk. To illustrate this concept, let's take an example. Suppose that a project has an 80% probability of producing a net present value of $2 million and a 20% probability of producing a net present value of $500,000. The expected net present value would be calculated as 0.8 times 2 million plus 0.2 times 0.5 million, which is equal to $1.7 million. This project could then be compared with another project which has a 50% probability of resulting in a NPV of 1.8 million and a 50% chance of producing an NPV of $1.6 million. The ENPV could be calculated as then 0.5 times 1.8 million plus 0.5 times 1.6 million, which is equal to $1.7 million. The risk-neutral decision maker would be indifferent between these two group projects, despite the difference in variability, and would opt to undertake both, provided that the projects are not mutually exclusive and there are no budget and other constraints. Now suppose that only one project can be undertaken and that the first project is redesigned so that it has an 80% chance of producing a net present value of 3 million and a 20% chance of yielding a net present value of $500,000. Thus ENPV is 0.8 times 3 million plus 0.2 times 0.5 million equal to 2.5 million, A risk-neutral decision maker will accept the redesigned project. However, another decision maker might choose the project with the lower expected net present value and the lower variability in outcome. So this decision maker would be acting in a risk-averse manner, and we could say that the cost of the uncertainty or the extent of risk aversion was some amount up to the difference between the two expected net present values, that is $800,000. Note that to know exactly the cost of uncertainty, we would need to know the risk-averse decision maker's certainty equivalent. It is the sum of money at which the decision maker is indifferent between the two alternatives, that is acceptance of the certain sum of money and acceptance of the uncertain project outcome are valued equally. The certainty equivalent is never less than the minimum payoff, in this instance $500,000. If it were less, the second decision maker would reject both alternatives. So the certainty equivalent has to be equal to or more than the minimum payoff.